Welcome to this class. We are looking at the sequence of control at the consumer intake point. Basically, we are looking at when the electricity board gives you power. What happens from that particular point? From that pole that is standing outside your house, what kind of wiring that goes on until you take power to your premises or to your house? That is basically what we are looking at. So the very first point, after the pole, you get a service cable. This is the line that is moving from that pole to your meter board. So after the cable comes, it goes through the service fuse and the neutral link. This is what is commonly called the cutout. Once now the power has come in to the cutout, it goes to the energy meter. And in most cases you will find the meter board has got these two, the cutout and the energy meter. So basically we have said from the pole, you get a service cable, the black cable, it goes through your cutout. After it goes through your cutout, it goes to the energy meter. From the energy meter, now you can take it to the consumer. At the consumer, we have the isolator switch. In this case, in most cases, we use the double ball circuit breaker. Then from there, you go to the bus bar, where of course you can be talking about the single pole miniatures, a circuit breaker, and such like. So basically, at the consumer intake point, we are having four equipments. We have the cutout, we have the energy meter, we have the main isolator switch, which in this case we are calling the double ball circuit breaker, and secondly we have the bus bar, the neutral link, the live bus bar, and the earth terminal. All these have been enclosed in the consumer box, which I've earlier on shown you. So this is what we are calling the consumer. This is what we are calling the consumer. After the energy meter, the power comes straight to this double pole. After the double pole, which is being represented here as this, we take it now to the MCBs, which is now distributing the power to the various circuits. I want now to take you through the wiring diagram. How do you connect the wiring diagram of this? Remember, this is the layout symbol, and in an examination situation, you will be presented with the symbols. Then now you will be able to interpret it and draw a wiring diagram. So you must understand how to draw a cutout in a circuit symbol, how to draw an energy meter, how to draw the isolator, how to draw the distribution board. In this case, we are talking about the MCBs, the miniature circuit breakers. So once you are there, we can now move to the wiring diagram. In the wiring diagram, you have you will start with the cutout. In the cutout, of course, we have said we are having two links. The first one is a fuse, and the second one is a neutral link. So the live passes through a fuse, then the neutral passes through just a link. So this is the cutout. The whole of this is a cutout. After that, we go to the meter, and you can see you tap the line from the pole, bring it to this connection, tap the live from that particular pole, and bring it to the fuse. After it passes through the fuse, bring it to line 1. Remember, this is our energy meter, and according to the setup, it clearly indicates that our meter has a coil of that type. So meaning this is line 1, and that is line 2 of the coil. So the light comes in through this point and leaves out through the other point. So if it leaves through this other point, you will take it to the switch fuse. Basically, this is called a switch fuse. I think I need to name this. Remember, this is an energy meter. And I've said this is our cutout. I will just have to indicate it as a cutout. That is our cutout. This is our energy meter. So once you have labeled that, after the power has gone through the energy meter, you now take it to the isolator. The isolator, in this case, we are using a switch fuse. In the switch fuse, remember a switch fuse, those are two things which are combined. It means it has a switch and it has a fuse. That is why the first portion represents a switch. The second portion represents a fuse. That is why it's called a switch fuse, because it has got two components combined together, switching, and it has a fuse. So it has double protection. You can manually isolate. It can also automatically isolate if the current goes beyond the rated current that is supposed to flow in that particular component. So you take your live, bring it to this side. Remember, this is the live and this is the neutral. The reason as to why we are saying this side is the live, remember the live must be having a fuse because it is a switch and a fuse. But the switch disconnects and connects both the live and the neutral. So once it goes through this point, it has to leave through the other side of the, so meaning this is the live wire, it goes to the live bus bar. So basically that means this is called a live bus bar. This one will be called the neutral. The neutral bus bar. So once you take your live to the live bus bar, you must connect the fuses. These are called the fuses. You can call these the fuses, or in short we can call them MCBs. Connect your MCBs here. The reason as why you are connecting the MCBs here is because different circuits have got different ratings. If it is the rating, if it is the circuit of a lighting circuit, of course you might use like 6 to 10 amperes. If you are using a socket outlet, you might want to use even 20 amperes. So that is why we are saying you must be having different MCBs, controlling different circuits. If it is a cooker socket, of course, there is a different power that you might need. So that is why you need different MCBs at that particular point. We have also said this is a neutral link. So from the energy meter, you need to take your neutral to the switch fuse. Remember I've said this is called a switch. That is called a switch fuse because it has a switch and a fuse. So once you have taken the neutral link to the other side, you need to now have a neutral going to circuit 1, get another neutral going to circuit 2, you get another neutral going to the circuit 3. So basically, this is what happens in a wiring diagram. And remember, we have interpreted what is in the layout diagram to the circuit diagram. I hope you have understood those points, and we are going now to stop there.